Okay, so we got 5 questions, and looking at the questions, determining what might be the easiest problem for you to do. I'm kind of looking at, I'm going to say 13, I'm not 13, 3. The reason I said 13 is I see a 13 the problem. 3 might be easy to do. So looking at it, what I'm going to do is I'm going to select 3, and I'm going to start to do something with it. And they say, what's the largest power of 2 that divides that number? I have no idea. So I'm just at 13 to the 4th power minus 11 to the 4th power over 2 to some power n. And what's the largest n could be to divide that? Now, one thing you do is just do the arithmetic, but I want to point out that looks like it's going to be a really tough arithmetic for me. So I'm going to try to factor it. So I'm going to say 13 squared minus 11 squared, and then you would get 13 squared plus 11 squared over 2 to the n. I still don't know what that is. But I'm kind of looking at it, and I'll go one step at a time. I get 13 minus 11, and then 13 plus 11, and then I get 2 to the n the bottom. And 13 squared is more manageable than 13 to the 4th power. It's 169. I can actually do that in my head. And 11 squared is 121. Again, I'm still struggling. I'm looking for that n. N's going to be some integer value, by the way. So 13 minus 11 is 2. 13 plus 11 is 24. And 169 plus 121, let's see, 170, 180, 290, right? 2 to the n. Well, I'm going to start writing 2's down. 2 to the 1st power. 24 has an 8 in it, so that's 2 cubed. That's a cube, by the way. Times, let's see, times 3, right? So 8 times 3 is 24, right? Now 290, more challenging for me. I know there's a 2, and that goes 145 times, and that's the end of the 2's now. So 2 times 145. There's no reason to factor 145 further. There are no 2's in it. So what's the most could be? 1, that's 3, that's 4, and another 1 over here. So it looks like n is 5. That's the maximum n could be, 5. All right? So that was number 3. Let me scroll to the answer key. And I said, that was number 3, right? Yeah, so we got that right over here. I see it right here. All right, let me go back and look at other ones. And I'm going to start to erase, just like I was at the whiteboard. Again, these are recorded. You can always go back and look at them. But what's in the blue areas should be sufficient. And, someone says, why do you record the video? Some people just need a walkthrough. All right, I'm going to look at another one. And looking at them, I'll be honest with you, 3 was pretty easy. And then I'm going to look at, I'm going to go for 2. All right, number 2. And let's write that down. So the first thing I would do is I like to solve things for 0 first. And that would be minus cosine to 5x. Now I realize some people's background in trigonometry is better than others, and maybe they can't remember these things, but I wouldn't worry about it so much. What I'm going to write down is I'm pretty sure that this can be written as, a plus b minus cosine a plus b equals 0, with the understanding that a plus b equals 7x. Now again, for students that have studied trigonometry, better than other students, this would be unnecessary. But, I'm sorry, I didn't mean to say a plus b. I couldn't possibly be. Let me get my eraser out. Now, if you wonder why I'm saying a plus b for 7x and a minus b for 5x, 5x is smaller than 7x, all right? So I'm going to write this over here, a minus b. And if I add those two equations together, what would I get? I would get 2a, the b would disappear, and then 7x and 5x would be 12x. So a would have to be 6x. So I think I'm ready to do this. I'm going to say the a is 6x here. I still don't know b, by the way. And the a over here is 6x. Let me erase it. And I got to get an eraser out. And that would be 6x. Well, I think it looks pretty easy now. What am I saying easy? By the way, this could be a dead end. But 6x plus x would be 7x. I'll get my eraser out and erase this now. And then b is x. So I'll write this over here. Let's just make sure it works out. so let's see, 6x and x, 7x, that looks pretty good. Yeah, looks good. All right, so not bad. Now I'm going to do something. Erase this here. And again, some students could have said that I could have done that in my head. That's fine. Do it in your head. I'm going to write these down, the sum formulas for these. And one at a time. I'll do the first guy. And again, could be a dead end. And then I'll do the second guy. So cosine 6x times cosine of x minus sine of 6x sine of x. Let's do the other one. Cosine of 6x times cosine of x plus sine of 6x, right? Sine of x. Let's see if we can do this. All right, it looks really bad, doesn't it? Let's take a look. So what I noticed right away, I noticed that this and this, they would just disappear. And then if I did this and this, I have to subtract it, right? So what would you get? You would get minus 2 sine 6x times sine of x equals 0. Well, I think I can handle this. I'm going to divide both sides by minus 2. I think I can do it pretty quickly, and I'll write that down for you. So sine of 6x. And to be honest with you, I kind of forgot what the question is. I want to go back and read it. And the question says, and this is number 2, it says they want to know what the solutions are in the interval between 0 and pi. Well, this is fairly easy to do because I'm just looking, when is the sine of x equal to 0? And I'm looking for when is the sine of x. I'm using the zero product rule, 6x equal to 0. And this is an OR. So I'm going to say this would be x equals, let's see, it would equal pi n, right? Where n is some integer. N is any old integer. And this would be 6x equals pi n. Again, n is any old integer. So let's start listing them down, but my answers x have to be on the interval between 0 and pi. Let's write them down. Certainly if n is 0, I'd get 0. Now if n is 1, I'd get the last one here, which is pi. But there's some in the middle. Let's talk about that. X is equal to pi over 6, n. I still get the 0, by the way, if I chose n to be 0. Now if I choose n to be 1, I get pi over 6. You know what? I don't need to put those square brackets on. I don't know why I did that. This is a set of numbers here. I'm going to go to n is 2, so we're going to get 2 pi over 6. And then I'm going to go to 3. That's 3 pi over 6. I'll clean this up later. Then 4 pi over 6. And then 5 pi over 6. And then 6 pi over 6, which is just pi. So what are my answers going to be? 0, pi over 6, pi over 3. I'm putting them in order. Pi over 2. Let's see, 2 pi over 3. 5 pi over 6. And pi. I'll put a circle on that. And what number was that? That was number 2. Took a long way to get there, right? Let's take a look, see if we got the right answer. And number 2, 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. Did I put those down? Pi over 6, pi over 3, pi over 2. Yeah, 632. 632. And then 2 pi over 3, 5 pi over 6. Yeah, I did good. All right, let's keep going. I'm going to get my eraser out. I'm looking around for something else to do. And again, this looks like a trig theme here, right? And the reason I'm saying that, I think I have another trig problem over here. So let's just make sure you know what I just did. I did 2. That wasn't too bad. I did 3, which is I say the lowest hanging piece of fruit. I'm going to do number 1 now. All right. Again, some people just do this by calculus, and there's nothing wrong with that. But I want to look for a pre-calc way of doing it. And it sort of reminds me of what I did over here, but not the same. It sort of reminds me of this. So I'm going to say something about this. It sort of looks like a sum formula to me. I'm saying it sort of looks like the sine of A plus X. Now what I mean by that, if I were to expand that, what I'd get is I would get sine of, oh, by the way, this is always less than or equal to 1. I know that much about the sine function. It's always less than or equal to 1. So what do I get over here? Let's take a look. I get the sine of A, cosine of X, let's see, plus, let's be very careful here. This would be the sine of X, cosine of A. And I know this is less than or equal to 1. All right, I got troubles though. I'll tell you what my troubles are. I'm seeing certain things in the problem. I'm definitely seeing the cosine of X here. And I'm definitely seeing the sine of X over here. But I got these other things I really didn't want to begin with. So I'm trying to think of a triangle where the hypotenuse would be 5. And I get the other numbers 3s and 4s. And let me write this one down. 3, I want the other one to be 3, because I'm seeing these numbers. I'm seeing the 5, I'm seeing the 4, I'm seeing the 3. And I got to think about this. There'll be some angle. I'm going to call it angle A. This is a right triangle. I should call it a reference triangle. Because there could be other ones, right? Not just a reference. And let's take a look. And if I'm taking a look at this, I want the sine of A. I want the coefficient of the cosine to be a 4, right? So let's try this. 4 and a 3. So I'm going to put this down. The sine of A reference would be equal to 4/5, right? And the sine, not sine, but cosine, let me get my eraser out. The cosine of A reference would be 3/5. Let's take a look. See if I'm getting what I want. Yeah, I think I would. All right, so I gotta be careful here because that's a reference angle and there's other angles, right? So I gotta be really careful about this. And let's take a look. Sine of A reference is 4/5. And the cosine of A is 3/5. Takes a little time to think through this, I'll be honest with you. So 3/5 sine X well, you know, there's possibilities over here. I hate to say this, but you realize I'm talking about A's could be anywhere in the universe. So I got to really think here carefully. And I'm saying, like, you know, if it's in the first quadrant, both of those functions are positive. Right? That's if the reference angle falls in the first quadrant. In the second, they would turn out to be positive, negative. This would be negative, negative. I don't have to worry about this, by the way. I'll tell you why. You know, negative numbers, if it's negative, it's always going to be below a positive number. I don't have to worry about this. And over here, I got to worry about this, though. This would be minus positive. So I got to make one of those things negative. And, you know, it really doesn't matter which one you do, because if they're both positive, that's fine. You know, let's write that one down first, when they're both positive. So when they're both positive, what would I get? I would get, this over here would be, the sine of A would be 4/5. They're both positive. I'll do this one over here. That would be cosine of X. Let's see if that works. Yeah, it looks pretty good. And the sine, I'm sorry, I did the sine of A, right? Now I'm going to do the cosine of A, and they're both positive, say 3/5. That would be sine X, and that's less than or equal to 1. And again, I'm saying the first quadrant, they're both positive. What do I go over there? Maybe I should put that down, a little arrow over here. that would be 4 cosine x plus 3 sine x would be less than or equal to 5. Is that true? Well, that's what they want me to show. Yeah, it's true. It followed from a premise that we know is true for real numbers, and that's good. So we did that. Let's do the other ones. Let's do these other two over here, and I'll write that one down for you. And this should be pretty easy to do too. All right, so let's put this one down. And the sine of A in the second quadrant is going to be positive number, right? So sine of A would be 4/5. And then they got cosine of x. And then the cosine of A would be negative in that quadrant. So that would be -4. I'm sorry, not -4. It's -3, right? Sorry about that. Sine of x would still be less than 1, or equal to it. Multiply both sides, you get 4 cosine x -3 sine x less than or equal to 1. 5, I mean 5, I'm sorry about that. Does that help me out? I think so, but it's not exactly the form I wanted, was it? So I'm going to write this over here. It's going to be, I'm going to multiply both sides by minus. It's still going to be made to be true, by the way, but I'll write this over here. And I want to see if that's really making any sense to me. So 3 sine x -4 cosine x greater than or equal to -5. I got to be a moment to think. You know what? I don't need to do that. Let me back up. Less than or equal to 5. Yeah, that's fine. I got this. I'm still getting this. I'm still getting the truth of this. All right, I'm still getting it. And the other one over here, likewise, similar argument. Let me write that down for you. Similar argument. That would be -4 cosine of x plus 3 sine of x less than or equal to 5. Yeah, I'm getting it. All right. So I think the trick here was to write this down, then this, and then look for a reference triangle that would give you those ratios that you wanted, which is a 4, a 3, and a 5 in it. And less than or equal to 1, regardless of the numbers I am choosing for A. And that's why I had to go those plus or minus things over there. I think okay on that one. So I want to look at the key. I want to see what the key does. And the key does something similar. And you get this business over here. Similar over here. I just wrote down the plus or minus 3/5 over here, the references. And yeah, same thing. All right? So they're just saying that this thing over here, I like the way they did it better because they didn't go through that struggling that I was doing. They just put this one over here. So, 4 cosine x plus or minus, which means two things. It means this over here, 4 cosine x plus 3 sine x is always going to be less than or equal to 5. We did show that. And the other one we showed was that, 4 cosine x minus 3 sine x was also less than or equal to 5. So they've been shown. I want to point out in the calculus department, which is not a bad way of doing it, what you have to do is write the function down, take its derivative, solve the derivative for zeros. It's the only thing is 0 in this one over here. Write it down, put down these numbers over here, and start to go through the analysis, determine where the minimum and maximum are occurring. And it's really not bad to do that, by the way. All right, you can go through that if you decide to do the calculus. Again, I probably think maybe that's probably overkill for a problem like this. You can do it pre-calculus. All right, so what have we done? We've done 1, 2, we've done 3. I haven't done 4. Looks tough to me. I'm going to go to 5. 5 says consider the set of all fractions x over y, where x and y are relatively prime. Now, if you know what that means, it just means, it says in number theory, two integers x and y are said to be relatively prime, mutually prime or coprime, also written coprime, if only positive integer factors that divide them both are 1. So I'm going to say, really, some people just simply say lowest terms, all right? There's no reducing factor between x and y, all right? They go on to say they're positive integers. Again, some keywords, relatively prime, positive integers, right? How many of these fractions have the property that if both the numerator and the denominator increase by 1, well, if their numerator and denominator increase by 1, they get this over here, right? How many of these fractions have the property that if both the numerator and the denominator are increased by 1, the value of the fraction increases by 10%? Well, let me write down what that means. If it's increasing by 10%, that would be 1 plus 10 over 100. That's a 10% increase, by the way. Well, it looks a little difficult to me. I'm going to try to figure it out now. And what do you get over here? X over y. And what do you get over here? Well, 10 over 100 is really 1/10. And 1 plus 1/10 is going to be 11/10. That's not so bad. And that's x plus 1 over y plus 1. And remember, x and y are integers, and they're in lowest terms. So let me see if I can do this. 11x, 10y equals x plus 1, y plus 1. I'm no longer thinking of the question, by the way, but you're going to get this. 11xy plus 11x equals 10xy plus 10y. All right, I'm in a little pickle right now. I don't know what to do. So I'm going to take 10x from both sides, 10xy from both sides. You get xy. All right. Let me make sure I did that. 11xy, 11x, 10xy, and 10y. Yeah, I guess I got to do something, right? So 10xy, I took that from both sides. I get xy, and then I get 10y minus 11x. It looked kind of crazy to me. I'm not gonna. That doesn't look too easy to analyze. So let me try this over here. 11x plus xy equals. You know what? I don't want to do that either. I'm gonna cross that one out. I'll try another one. I'm looking for something really easy to analyze. So I'm going to put down 11x. 11 is a prime number, by the way. 11x would be equal to 10y minus xy. Before I go further, I want to make sure I did the right thing. So minus 11x, I add 11x to both sides, subtract away xy. I did it right. I'm going to factor this guy. And I'm going to say y comes out. And then what are you left off with? 10 minus x. Again, I want to remind you that x and y do not share a divisor, and x and y are integer numbers. So I'm starting to look at this, and I'm hoping that it's not that difficult to look at this and look at this over here. So I'm going to say one possibility for this to be an equality, and again, everything's integer, x and y do not share any factors in common. Right? I'm going to say y could be 1, or y could be 11. Now I got to reason through this now. I'm going to see if I can get it. I'm going to get this erased. Now, this is something from old problem, right? I don't need that anymore. So let's just take the y to be 1 now. So if y is 1, what do you get? You get 11x equals, I'm just checking to see if it works out. If y is 1, I get 10 minus x. Let's say I did that right. So if y is 1, I get 11x, 10 minus x, and I would get 12x equals 10. Well, you know what? X is not an integer. So this couldn't be. All right, x is not an integer. So what's x over here? Let me write this down over here. X would be 12 tenths. I'm sorry, 10 twelfths, which is 5/6. That's bad news. All right, I hope I don't hit a dead end with the 11. Let's try this. So it's 11x. If y is 11, I'm on this one now. And then I get 10 minus x. Well, I'm going to divide both sides by 11, so x would equal 10 minus x. I'm sure I did that right. Divide by 11. Yep, I'm doing okay. And then I'm going to add x to both sides. That's 2x equals 10. Well, lo and behold, x does turn out to be an integer in this case. You get 5. All right, so what's x? X is 5. What's y? Y is 11. Now, by the way, what's the question? What's the question? Consider all fractions, blah, 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 blah. How many of these fractions have the property that both numerator and denominator increase by 1, the value of the fraction is increased by 10%? I only found one. There's only one. And what's that? That's going to be the ratio, again, x over y. So the answer would be the only ratio of integers that are relatively prime to one another are 5 over 11. Okay? Let's look at the answer key. And I think this is going to be number 5, right? I'm going to number 5. And let's see if I did that. Yeah, it's only one possibility. The only possibility is 5/11, as we stated. All right, let's go back and see how we're doing. I know this is difficult and time-consuming. Remember, I know I erase a lot after I do something. It's only I feel like I'm at the whiteboard and we're racing through problems. What's nice about we're really not the whiteboard. I'm on a computer. You can always pause these tapes and do what you need to do to get them right. Okay, and also put nice typeset answers for you in the notes itself. All right. I'm gonna start to erase my work, and I'm gonna start saying I want to do another question now, and my confidence is kind of shooting up. And don't be discouraged if your confidence is not shooting up. Stress sometimes is overemphasized. Stress is actually a good thing if you're stressing over things, saying I don't know where I could get that answer from. You think about it, and although competitions are time based, for the most part, good thinking shouldn't be time based. You take your time. All right. So I want to just tell you what I think we've done so far. I think we did 1. You remember doing that. I think we did 2. I think you remember doing that. I did 3, and I did 5. Now, I saved 4 for last because I thought it looked like a really bad problem. But, some of those things aren't as bad as they look. But I'm going to write this down for you. And it says F0 is 0. F1. Now, a lot of people might assume, that this is a Fibonacci sequence or something. But I don't know. Maybe it is. Maybe it's not. Oh, you know what? I got to correct this notation over here. And let me write this down. This is going to be F n minus 1. You're not going to see this in your notes, by the way. F n minus 2. Sorry about that. It says that it's the remainder when we divide the prior two terms by 3. So let's write this down. So what's F2 going to be? Well, if you add the prior two terms together, it's going to be 1 plus 0. And if you divide by 3, 1 divided by 3, its remainder would be 1. All right, now let's do the next one. And I'll keep doing this until I see a pattern. And I'm hoping to see a pattern, by the way, because when I see a pattern, I'm really kind of lost. I'll erase this one over here. And the next one says, you add the prior two terms together, 1 plus 1, and divide by 3, and now it would be 2 divided by 3, and you take its remainder. Well, if you divide 2 by 3, its remainder is 2. All right, let's keep going. F4. Let me get my eraser out. I'm going to erase this business. I'm going to do it. I'll do it for a while until I definitely see a pattern. Something that I know is going to repeat itself. So what's F4 going to be? 2 plus 1 over 3. 2 plus 1 is 3. Whoops. And 3 divided by 3 is 1. Its remainder is 0. So, if we get 1 again, I guess we'd be back in a pattern, right? So let's do this one over here. F5. 0 plus 2 divided by 3 is 2 divided by 3. Well, you know what? Its remainder is 2. I don't have a pattern yet. Let's keep going. F6. 2 plus 0 divided by 3. Let's see if we're doing this right. By the way, they do give me the sequence, by the way, but I'm just seeing if I can do it. 0, 1, 1, 2, 0, 2. They didn't give me this number, though, did they? So 2 plus 0, the prior two terms, by the way, is 2. And 2 divided by 3, its remainder is 2. All right, F7. I'm not seeing any repeats at this point. All right, and let's go to 2 plus 2 is 4. And 4 divided by 3 has a remainder of 1. Let's keep going. Let's do F8. Well, F8 is going to be 1 plus 2. And 1 plus 2 divided by 3, that's going to be 3 divided by 3. It has no remainder. Right, I'm back, I'm pretty sure at the beginning, but you can keep going if you want. All right, what I mean by that is if I'm at the 0 now, and, certainly, if I put F9 down, right, what would it be? 0 plus 1, they're the prior two terms, by the way, which is 1 divided by 3. I'd be back in the same sequence. So I'm going to say, it's really not that bad to do. So I'm going to say F8 is equal to 0, F9 is equal to 1. I don't need to compute them anymore. You can if you want. I'm not saying you can't, but I don't need to compute them anymore. So I'm going to erase these over here. And I could write these down forever. I'll be honest with you, it'd be a lot of work though, right? Whoops, sorry about that. 7, 8, 9, 10, 11, 12, 13, 14. And by the way, I'm saying this is true. I'm seeing a pattern. And that would be what? Let me make sure the 8, 9, 10, 11, 12, 13, 14, 15. And, the bottom line is there's a pattern, all right? And so what is the pattern? Well, there's many ways to look at it. But what I'm going to do is, I got to get to their question, but I definitely see a repeating pattern. What's their question? Their question is this. I need to get up to these guys over here and find out what the sum is. So I need to get to these guys. And that looks like it might be a lot of work, right? But I'm going to look at it, and I'm looking for a number in that sequence that might be easy to get to. Like what number is easy to get to? And, kind of looking at it, I'm going to go to the F2024. Let me write this down. And I'm pretty sure that's some multiple of 8. So I got 0, 8. You get the idea, right? So I'm gonna just do that for you. I'm gonna do 2024 is some multiple of 8. I think so, right? So it's gonna be 1012 divided by 4. That would be what? 506 divided by 2. And this is clearly the case, right? So you get 253, right? That's not bad. So I know if I follow this sequence along, I'll eventually get to F2024, and that would be 0. You get the idea? But I got to go backwards. And why is that? I'm here, and then I got to go before 0. Well, what's before 0? The 1. What's before the 1? A 2. What's before the 2? A 2. And then a 0, right? I'm going to match these up, by the way, and make sure I'm doing this. This is 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 this. And I'll check before I add it together, by the way. I don't want to get it wrong. So what's the next one going to be? 2. And then 1. and then 1. All right, let me match them all up. Whoops, I didn't mean to do that. All right, I want to add it all together. All right, so I did find this, and I know that that 0 would be there, and again, I went backwards from it, right? I went backwards. That's all I've done. All right, let's add together. 1 plus 1 is 2, 4, 6, 8, 9. Let's see how we did. What number is that? 5, right? Whoops, went too far. That's not 5, it was 4 or something, yeah. Yeah, 9. All right. So they did a little bit different. It has a period of 8, though. All right, they're a little bit different than we did it, but the sum's 9. All right, 1, 1 goes up to 0. Yep, 1, 1 goes up to 0. Period of 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Period of 8. Okay, let me repeat what I think was the easy question on the this thing over here. I believe this was the easiest one to do. This one here really wasn't that bad to do. Let me see what else. Number 2 wasn't bad to do. Number 1's tricky, and number 4 was pretty tricky. All right, I had to think about it. I want to remind you, if you need to reach out to me, my email address is Bannon. I want to give you a little warning if it becomes popular, which is highly unlikely. You know, I'd say stupid cat videos on YouTube are highly popular, but math is probably not that popular, except for those few exceptions where those sites are promoting things and they have really slick videos. I'm not promoting, I don't have slick videos. But anyway, if you want to reach out to me, my email address is, again, Bannon, B as in boy, ANNON.US. But the deal is this: if I get overwhelmed by people asking questions, I can't answer everyone's question. All right? I don't think it'll ever get to that stage, though. Thank you so much for paying attention. I do appreciate your time and your patience. And if you're working these problems without looking at this stuff, I really do appreciate it as well. We'll have a better world by people working on problems. Thank you.